So hello guys, welcome back to the new video. So today we are going to solve this question, which is divide nodes into maximum number of groups. I think this question is marked as hard, but from your intuition, you are able to generate the solution for this question. So let me explain you the first. I'll explain you the question, and then we'll move to the approach, how to solve this approach. So don't think that this question is marked as hard means it's difficult. No, there are some questions in the Leetcode which are marked as hard because of the implementation parts, not because of the logic thinking part. Yeah, so this is one of the that kind of question which is difficult in terms of implementation, because here we have to implement more the means 2 3 different algorithm. That's why. But yeah, intuition wise and so solution wise, it's very intuitive to solve this kind of problem. Okay, so now let's read first the question. So we have given a positive integer n representing number of node in undirected graph, and they are labeled from 1 to n. Okay, now you are given a 2D integer. So as we have given undirected graph, so yeah, there is two thing which is there. Either the first thing is this: if we have given any graph, then the possibility that the graph is given in terms of adjacency matrix or the adjacency list. So what they have mentioned here, so you are given a 2D integer edges where edges of I means a of I, ai bi means ai is our u and bi is our v. Means if there is a edge from u to v, but is this is undirected graph, means there is a edge from u to v also and v to u also, indicates that there is a bidirectional edge between AI and BI, as I mentioned that it is a undirected graph. Okay, so now what's the next thing? Notice that the given graph may be disconnected. Yeah. So first let me tell you that this is the important thing, because many person will miss that thing. Divide the nodes of the graph into m groups such that, okay, now what we have to do here, we have to divide into m groups. Okay, each node in the graph belongs to exactly one group. Okay, this is our first condition. The second condition is every pair of node in a graph are connected by an edge ai bi. Means if there is a edge between u to v, then this is belongs to one group, let's say x, and this is belongs to one group, let's say y, then the difference between these two is positive. Positive, it means like if 1 2. Okay, so this is level 1, this is level 2, so difference is -1, and mod means 2. Understood? Return the maximum number of groups into which you can divide the nodes, and return -1. It is impossible to group the nodes with the given condition. Okay, so let's start with this example. Let's first build the tree. Okay, so we have 1 2, as in the input also given there are 6 node. So let me first write the 6 node. Yeah, that's all. Now we have edges from 1 to 2. It's bidirectional. Then 1 to 4, 1 to 5, then 2 to 6, 2 to 3, and 4 to 6. Okay, now we have to divide this in a group. So how we will divide, will make in the group, as we have two conditions, each node in the separate group, and if there is a edge between ai to bi, then the difference will be 1. Understood? Yeah, that's very easy part. Now let's say how we will do it. How here we got answer as 4. So what we are doing here, let's say we are starting from here 1. Hmm? Now we have to think about the two case. Okay, so which are the two case possible? So as they mentioned that return -1, it means that if it's impossible, means there is some possibility where we are not getting any answer. So let's first discuss about that possibility, and then we will move to solve the given test case. So let's say the first test case, the two condition you have to keep in your mind while solving this question. The first condition is that each node should be in the different group, and if there is a edge between u to v, then the level or the group difference between both that node will be 1. So let's say I have 1 2. So this is my example 1. Okay, so what will happen here? So this is 1, this is 2. So if I'll try to separate this two thing into the group, then what will happen? So let's say this is part in the, this will be in the group number 1, then this will be in the group number 2. Okay, so 2 group. So as we can say, the output is here 2. Okay. Okay, so let's check whether we are able to satisfy the two condition. Okay, so this is in the group 1, this is in the group 2. So first condition is satisfied. Now what will be the second condition? The second condition is if there is a edge between you two, then both are in the different. Now, um, yeah, this was our first example. Now let's we have graph as this. What will be the output here? So what we will do, we will first give this node as level 1. Okay, now we think, let's give both of this node as level 2, because yeah, this is our first and this is 2. But now this is not possible case. Why? As there is a edge between 2 to 3, so the difference between level of this 2 and 3 should be 1, not 0. And here we are getting at 0 because both are at same level. So this case is fail. Okay, so if we are thinking to change, if we can do any other way, let's we are dividing here, we are giving this as level 2 and this is level 3. Okay, so this is also wrong. Why? Because there is a edge between 1 to 2. So 1 at level 1, 2 at level 3. So difference is 2. It's also wrong. So as you can see that if you are trying here, if you will try any possibility, but you are not able to achieve the solution. So what will be the answer here? So now my answer will be here -1. Understood? Okay, so this is the case where we are not getting answer. So many of you might think that okay, I got a tuition, like if we have cycle, then we will not get a answer anything. Okay, let me give you one more example. Yeah, this is our one more example. What we will do here, we are giving this one as node 1. Now this is node 2 and this is level 3, group 3, level 3, anything that you want to say. Now, many of you think that this is wrong. No, this is correct. Our output here is 3. Now, let's see why here output is 3. So, this is our group 1. Okay. Now, there is a edge between 1 to 2 and 1 to 4. So, both are should be at the difference of level 1. Okay. So, 1 is level 2, difference is 1. Level 2, difference is level 1. Understood? Okay, so this is satisfied, this is satisfying, this is satisfying. Now let's say if we have edge between 2 to 3 and 4 to 3, then it's also should be with the difference of level 1. So there is a difference of 1, 2 minus 3. Yeah, here also 2 minus 3, difference is 1. So this is our answer. So from this 3 example, we can conclude one thing. Okay, so what's the one thing is that if our graph has cycle. Okay, if our graph has cycle, means it's not like that we have just whole graph is as a cycle. No, if there is somewhere cycle possible, somewhere there in the cycle, means let me give you this example. If we have this, so here we don't have a cycle in whole graph, but there is a cycle in the component. So yeah, then this is satisfied in this case. Then what we will do, if we have a graph, if our graph has a cycle, then we have to check two things. The first thing will be if length is odd. Okay, if our length is odd, then we can say here answer not possible. Answer is -1. Now, the other case, when length is even, then answer is possible. Now many of you might say that this graph is not have a cycle. Yeah, it has a cycle of length 0. It is cycle of length 4, cycle of length 3 means odd, cycle of length 0 means even. Okay, then we have two possibilities of answer. Now first we will check this part. If its cycle has a length odd, then our answer will be -1. Now what are the other cases? Other cases is if length is even. So if length is even, then we have this kind of possibility. Okay, now length is even, then what we have to do? When our length is even and we want to find the maximum number of group. So if you remembered, do you have idea of BFS, right? So what we will do in the BFS, we will start at at any vertex and we are moving level wise. So as when I explaining these questions or this example, at the time also I'm mentioning group as a level, because let's say this is our, we are starting from here, then we are going from here to here, and then from here to here. So what we are doing, we are just doing the BFS kind of thing also, but level wise. So that we have to do here also to find the maximum level. So now second thing is length is even, what we will do in the sub point, if length is even, then we will find level using BFS. Okay, now the graph has also disconnected component. In that case, what we have to do? Okay, so let's see if we have graph like 1, 2, 3, 4, 5, 6, 7, 8. Now what will be answer here? So the total answer here is, this is in group 1, this is in group 2. So from here we are getting two group. Same thing we will get here too. Same here we will get here too. And these two are different. Means they two are isolated vertex. Means the vertex which are not connected with any other. Means in degree 0, out degree 0. So for here also we are getting one, and for this also we are getting one. So our total answer will be the sum of all this node, sum of all these connected components sum, which is 2, 2, 2, 2, 2 plus 2, 4 plus 2, 6 and 8. So our answer will be 8. Okay, so the same thing we will do. So first we will check if there is any odd length cycle. No, there is no odd length cycle. It means we have all even length cycle. Now then what we will do, we don't know from which vertex we will starting, so that we will get the maximum levels. So what we are doing here, we are finding the levels for, or we are doing the BFS for all the node. So from this node also we are doing BFS, from this also, this also, this also, this all the node we have, and we will store the answer in our array for the future reference. Now what we will do, now we are again starting from the each vertex, but now here we are going now component wise. How we can go the component wise, we can use any of the browser, either the BFS or the DFS, to find the number of components, and we from that components we have to find the maximum. So let's say a hypothetical situation, this has 4, there is one another node X which has level, maximum level from that node is 5. So now what we will do, we will say, let's say take a one dummy variable with maximum level as 1. Now we will apply the BFS or DFS any, and at that time when we are visiting a node, we are finding the level of that node, and if it's greater than our current value, then we are maximizing it, mark it at visited, and go to the next level. Understood? That's we will do for all the components. So at end we will get the maximum from that component. As here, let's say, from if we are doing the DFS, is DFS, sorry, BFS for each node. As I mentioned earlier, we have to do BFS for each node, because we don't know from which node we are starting to traverse, so that we are getting the maximum number of groups. So we will have to go for each node. So let's say for the first, if we are starting from the node 1, then we will get 1. If we are 2, then number of group as 4. If we will do the X, let's say some node X, then we will get the number of group as 5. But the overall maximum group is 5. So we have to traverse again all of this. So again we have to use any traversal technique of the graph. Yeah, same thing we will do for this component, same thing we will do for this, then this and this, and then we will do the summation of all of this, and at the end we will get our result. So I am writing my algorithm here only. So first we will check if the length is odd, answer -1. Length is even, we will find level using BFS. Okay, now it means that for each node we have how many group possible. That's we have for each node. Now we want to find the maximum for each component. So what we will do, we will traverse component wise and find maximum for in each component, and then we add a result of all component and return it. So yeah, this is the solution of this question. If you are implementing this, then you'll able to answer or you'll able to pass all the test cases. Now, why it's hard? It's hard because of the implementation part. Like here, you have to implement the BFS. Here also you have to implement the BFS or DFS, and here you have to also implement the BFS, but not just BFS. You have to implement the logic of bipartite, because using the whether the graph is bipartite or not, you are able to answer that it contains the odd cycle or not. So here first you will implement the bipartite graph logic. After that, here you are checking if the graph is BFS. Here you are checking if the graph for each node. Here you will find for each node the number of group as you are doing the BFS level wise, and here also you are again either you can do the BFS or DFS to find number of component in the maximum in all the component, maximum in that component. Okay, and then you'll do at the end of this sum. So if you like this video, then do like, do share with your friends, and we'll meet in the next video. Thank you.